Again, welcome to lecture number 4. This is Mathematics 200, which is a business calculus at NJCU. In lecture number 4, we are going to continue with our derivative formulas. In the previous lectures, which is lecture number 3, we talked about the derivative using the limiting process. And I mentioned that that's a very long process. Now we will get more detail into derivatives by using the formulas. So here we're going to learn the formulas for power, constant, sum, and difference. So first we start with the power. So derivative of a function f at x equal to s to the power n. So this is a power rule. The answer will be n times x raised to the power n minus 1. So the formula is given to us to be n x n minus 1. So again, this is called the powers of s rule derivative. Our first rule or formula is the powers. So if I have a function f at s equal to s to the power n, the derivative of this function will be n times x raised to the power n minus 1. And in this textbook, we are using the symbol f at s derivative with the apostrophe. So we have x n minus 1. Again, we're going to see some examples now. So first example, they say we should find the derivative of u at x equal to s raised to the power 8. So here our answer should be 8 times s raised to the power 7, because 8 minus 1 is 7. And also p equal to q raised to the power 2/3. The answer will be 2/3 times q raised to the power 2/3 minus 1. C, we have a c at t equal to square root of t. We know that the square root is a power half. So square root of t is the same as t raised to the power half. So our answer will be half times t raised to the power half minus 1. Also, we have ds equal to 1 over square root of t. Again, this will give us t, square root of t is t to the power half. So it's the same as writing s equal to t raised to the power negative half. Then our answer will be negative half times t raised to the power negative half minus 1. So I'm using the power rule now. So let's see the solutions. So this is our first solution, u at s raised to the power 8. So it will be what? 8, which is the power, times s raised to the power minus 1. So 8 minus 1. So our final solution will be 8 s raised to the power 7. Let's see the second example. If p equal to q to the power 2/3, then the derivative of p is 2/3 q 2/3 minus 1. 2/3 q 2/3 minus 1. And the final answer will be 2/3 q. 2/3 minus 1 is minus 1/3. So we can write the answer is 2/3 q to the power negative 1/3, or we change the negative power to positive. So q 1/3 will be denominator, which is 2 over 3q positive 1/3. So we can see again, derivative is based on these rules. This is our first rule. So let's go to the example C and D also. So C, I know that square root of t is the same as t raised to the power half. So the derivative of c at t will be half t raised to the power half minus 1. Always the exponent multiplied by the base, and that base will raise to the exponent minus 1. So the exponent is half. So we get half times t to the power half minus 1. And let's go to the previous examples. S to the power 8. So the answer will be 8 times S, 8 minus 1, which is 7 and 8. 2/3. So it will be 2/3 times Q, 2/3 minus 1. Now let's see the last example. So the last example, we have 1 over square root of t. We know again, square root is exponent half, so 1 over t half. And I want to bring the t to the numerator. Right now it's denominator, the down. I want to bring it up. So this will be negative half now. So our final solution will be negative half times t raised to the power negative half minus 1, which we have right here. And we can change the negative 3/2 to positive by bringing it down. So again, we get negative half t, negative half minus 1, which gives us negative half t raised to the power 3/2, which gives us negative half times, we are changing the negative exponent to positive, so it will be 1 over reciprocal, 1 over 3/2, and t raised to the power 3/2. Then we can combine the two here. So that's the derivative of a power rule. The next derivative of a constant, and this is the most easy one. Derivative of a constant value is 0. That's it. So if I have f at s equal to c, and c is a constant value, then derivative of f at x is 0. And let's see, again, we're going to see example together. So next, we have derivative of c, which is a constant value, times u at x. This means we have a constant value times coefficient times the variable. So let's see, the power rule, again, the rule here is very straightforward. We use the constant, we leave our constant value, then we use the power. It again depends. Right now, we only study the power rule. So the example given will be a power rule here. So let's see an example soon. So f at x equal to c times u at x. The derivative of f at x means I'll keep the c, then I'll find the derivative of u at x. So we have derivative. Again, we can see the apostrophe derivative. So c constant, then there is derivative. So this is called the coefficient rules. Says that the derivative of a constant value times a function is the constant times the derivative of the function. So our function is u at x. So then we leave the constant value. And again, we're going to see it. Okay, so this is example now. So f at s equal to 4s to the power 5th. I will leave the 4, it's a coefficient, I won't touch it. Then I'll find the derivative of s to the power 5th, which will be 5 times x raised to the power 5 minus 1, which will be 4. So that will give us 20 s to the power 4. So let's go through these 3 examples. So the first one, again, we have our constant value 4, so I didn't touch it. I find the derivative of s to the power 5th, which will give me 5s to the power 4 using the power rule. Then we can multiply 4 by 5, and that will give us 20. Let's try the second one. Derivative of g at t. Again, I have half, so I didn't touch it. I leave it. Now, power rule for t squared will be t times 2, and t have to be raised to the power 2 minus 1. So we get half, which is our coefficient. We don't touch it. Then the derivative of t squared will be 2t raised to the power 2 minus 1, which will be 1. So it's t. And that's what we have here, half 2t. So the answer will be t. And the last one, we have 5 square root of, divided by square root of q. So we can change this to a negative so that we bring the q up. So we get 5q raised to the power negative half, which is what we have here. So we don't touch the 5. We have negative half times q raised to the power negative half minus 1, which will give us negative 3/2. And also 5 times negative half will give me negative 5 by 2. So we have negative 5 by 2. And we change this, our expression, to a positive value. So we bring Q down and we get 3, 2, which is the same. 2 is denominator, so it's square root. And the last rule we are going to learn in this lecture is the sum and differences. So in this section, we are learning 3 rules: power rule, constant with a function rule, then derivative of sum and differences. So here they tell us that if we have a function f at x equal to u at x plus v at x, the derivative of f at x will be just a derivative of u at x plus derivative of v at x. Same thing applies to the differences. If I have 2 functions that they are subtracting or they are adding, just find the derivative of each function separately. So this would be the derivative of u at x minus derivative of v at x. So again, the rule for sum and difference, if I have, and again, the function can be as many as we want. For example, u at x plus v at x plus g at x plus w at x. All I need to do is find the derivative of each function and combine, add together. Same thing with the differences also. So let's see an example. Y equal to 3x plus 5. Let's solve that one first. So the derivative of y will be what? Derivative of 3x plus what? Derivative of 5. We know that derivative of 5 is a constant value, so the answer will be 0. Derivative of 3x, the answer is 3. The reason why, because x is raised to the power 1. So 1 times 3 is 3. And 1 minus 1 will be 0. So any value or variable raised to the power 0 is 1. So that's why we get 1 here. Because this will give it s raised to the power 1 minus 1, which will be s raised to the power 0. S raised to the power, any value or variable raised to the power 0, the answer is 1. Let's try the second one. Here they say the rules regarding the derivative of sums and difference of 2 functions also apply if more than 2 functions are involved. And as I said earlier, here, for example, we have 4 functions involved. But again, can be as many. The only thing is that we have to find the derivative of each component or each element. Then we combine if possible. So this is the solution. We find the derivative of 4x. Let's go back to the question. We find the derivative of 4x cubed, which will give me 4 times 3x raised to the power 3 minus 1. So I'll get 12x squared. Derivative of 2x squared will be 2 times 2x raised to the power 2 minus 1, which will be 4x. Derivative of 5x will be 5 times 1 is 5. S raised to the power 1 minus 1 is 0. So s raised to the power 0 is 1. So derivative of 5x will be 5. And the derivative of any constant value is 0. So that's what we have here. The constant value is 0. The derivative of 5x is 5 times 1. And we have 2x squared. And then, so later we can combine, if possible, as we know, polynomial like terms combined together. Here we have 12 times 12x squared. And here 4x, then here 5. Now the next question says we should find all points on the graph of f at x, which is s cubed plus 3s squared minus 45s plus 4, where the tangent line is horizontal. This again, the term tangent line is horizontal, bring the concept of finding the derivative. So the horizontal line has a slope which equal to 0. We know the tangent line, if it's horizontal, the slope is 0. That's to find the desired points, we solve derivative of f at x equal to 0. Because here they say find all points on the graph of f at x, s cubed plus 3s squared minus 45s plus 4, where the tangent line is horizontal. So when the tangent line is horizontal means the slope equal to 0. So we find the derivative of every the element here, which we have 4, and the answer will equal to 0, then we find the values of. So the derivative will give us, of course, s cubed will be 3s squared, because it will be 3 minus 1. Then the next one will give me 6x. 2 minus 1 is 1, so 6x. 45. Derivative of constant value 4 is 0. Then I will equate our solution to 0, because horizontal, the tangent line is horizontal. Then we find the value again of the x. Here we factorize it, we get s squared plus 2s minus 12. 3 is common among. Then we can try and do this. And we get s plus 5, s minus 3. This is factorizing trinomial. We have 2 here, positive 2. I know 3 times 5 is 15. And I need positive 2 when I combine, so I'll say positive 5, negative 3 multiply will give me negative 15. When I combine positive 5 and negative 3, I'll get positive 2. So we get positive 5, and then so the answer will be again s equal to 3 and negative 5. So those are the 2 points on x. Now when we get those 2 values, we can plug it in a function to get the y values. We are plotting it in the original function. So you see here, we say f at negative 5, not f derivative, f. So we get original function. And we can see the horizontal line. So the last section is marginal revenue. When we hear the term marginal revenue, it means we should find the derivative of something, a rate of change in the revenue. So a marginal revenue is used to estimate the change in revenue caused by sale of one additional unit. And we know in derivative, we are talking about change in any scenarios, any conditions. So a question is given to us here. They say, suppose that a manufacturer of a product knows that because of demand for this product, its revenue is given as following: 1,500x minus 0.02x squared. The x value is between 0 to 1,000, where x is the number of units sold and r at x is in dollars. Now they say find the marginal revenue at x equal to 500. So since we are going to find the marginal revenue, first we find the derivative of r at x. When we get the solution, we substitute 500 for x, and that will be our marginal revenue. Second, they say we should find the change in revenue caused by the increase in sales from 500 to 501 units. So again, here we have this equation here, r at x equal to 1,500x minus 0.02x squared. So the marginal revenue will be, find the derivative of it. And here we are looking for marginal revenue when normal product sold is 500. So we find again the derivative. Looking at the function, 1,500x means 1,500. 0.02x squared means 0.04x. So 0.04x, 1,500. Then we substitute 500 for x, and we get 1,480. So that will be our marginal revenue. So here we can interpret that this means that there's approximate revenue from the sales of 501 units will be this amount. Now, since we already know this, we can find the revenue at s equal to 500, and then the revenue at s equal to 501. Then we find the change, the difference, which will give us the same thing. So we can use 2 ways. I can use the actual value, the 500, inside the function, and 501 inside the function, because the rate of change of 1 unit. So if I'm in 500, from 500 to 501. So if that is the case, take the original function, substitute 500 in, take the original function, substitute 501 for x's. Then after you get the answer, find the difference. So you see that we almost get the same answer as we get. Or the best way, find the derivative of the function, then substitute for. That's what we did. Substitute x 500. So both the answers will be the same. Okay, so this will be the conclusion of our lecture number 4. In this lecture, we talk about derivative formulas for, again, power rule, constant, sum, and differences. So again, wish everybody the best. Thank you. This video is in YouTube, so you can comment on it so that maybe I may improve on my future video. If you see anything, if it's good, let me know. If something you think would be more better to improve it, let me know. Or you can like it and also subscribe it. Thank you.